Alright folks, just want to record a video to recap kind of what we did in class today. So I'll just pick up where we started, which was 2D. We're talking about type 2 error. So type 2 error is when you accept a lie. In other words, you accept a false null hypothesis. In other words, in the context of problem number 2, remember problem number 2 was about Mike, so I should write it up here. Remember, the null hypothesis was that his free throw percentage equals 0.5. The alternative is that the free throw percentage is greater than 0.5. And type 2 error is, in this problem, what? We incorrectly accept that Mike's free throw percentage is equal to 0.5 and conclude, equal to 0.5, when in reality the free throw percentage is greater than 0.5. So type 2 error is accepting a lie, right, or accepting a false null hypothesis. In this case, it is incorrectly accepting that Mike's free throw percentage equals 50%, when in reality the free throw percentage is greater than 50%. Okay, let's do 7D. Now this is a problem on the back with regards to the dog training programs. Okay, and here we have a statement. Remember, our H0 was that the training programs are equal. Our HA is that they are different. Let's finish up here strong. So type 2 error. Type 2 error is, we just said, accepting a lie. Type 2 error is when you accept a false null hypothesis. In this case, it is incorrectly accepting that the average hours from A equals B, when in reality they are different. Alright, so type 2 error, accepting a lie, accepting a false null hypothesis, incorrectly accepting that the average hours from A equals the average in B, when in reality they're different. Now, a concept closely related to type 2 error is power. Power equals 1 minus beta. Beta is just the likelihood of type 2 error. I pointed out in class that we will not calculate a number for this. Right? And we said that, well, if beta is high, the power is low. If beta is small, the power is higher. We want the power to be high, right? So we need to know a couple ways to increase power. So power increases when, 1, sample size increases. Sample size increase leads to less variance, which leads to less error, which leads to higher power. We said that the downside is, well, it's expensive to survey more people. It's expensive to just keep on increasing this. Power can also be increased if the significance level increases. Why? Because if the significance level increases, then the type 1 error likelihood increases, meaning what? Meaning that the type 2 error, because you can't have both, you either have type 1 or you have type 2. You either have type 1 or you have type 2, and